I'm excited to share with you a fundamental forecasting model in machine learning known as linear regression. Linear regression is a statistical method that models the linear relationship between a dependent variable and one or more independent variables. It's based on several key assumptions. The relationship between variables is linear. The dependent variable is normally distributed at each value of the independent variable. The variance of the dependent variable is the same at every value of the independent variable, and the observations are independent. These assumptions are crucial for the model's validity and reliability. Let's step into simple linear regression, where we have one independent variable and one dependent variable. Consider predicting a car's fuel efficiency based on its weight. We plot our dataset and use linear regression to find the best fit line that passes through these points. This line, represented by the equation y equals a plus bx plus the error term, where a is the intercept and b is the slope, help us understand how changes in weight affects fuel efficiency. The slope tells us the change in miles per gallon for each unit increases in weight, and the y-intercept is the accepted fuel efficiency when car's weight is 0. To find the parameters in our linear regression equation, we use the method of least squares. This method minimizes the sum of the square differences between the observed values and the values predicted by the line. The slope is calculated as the covariance of the independent variable x and the dependent variable y divided by the variance of x. The y-intercept is calculated as the mean of y minus the product of the slope and the mean of x. These calculations ensure that our line is best fit as close as possible to all data points, minimizing the error. Now, with this model, we can make a prediction that a 4,000-pound car would have a predicted fuel efficiency of 15.6 miles per gallon. Now, let's move to multiple linear regression, which extends simple linear regression to more than one independent variable. For instance, predicting house prices based on size, number of rooms, and distance from the city center. Here's a dataset with these features and their corresponding house prices. We can use this data to build a model that predicts house prices based on these factors. The equation for multiple linear regression is y equals to beta 1, beta 0 plus beta 1 x1 plus beta 2 x2 plus theta n xn and plus the error term, where beta 1 is the y-intercept and beta 1 to beta n are the coefficients for each independent variable x1 to xn. Looking at this dataset, we can see the correlation between house size, number of rooms, and distance from the city center with house prices. A larger size and fewer rooms closer to city center tend to have higher prices. To find the coefficients for our model, we again use the method of least squares, but now we have to consider the interactions between multiple variables. When calculating the parameters in a multiple linear regression model, we need to reorganize it into a matrix equation form and calculate the derivative towards beta to find the value of 4 parameters. After we have got the equation of our multiple linear regression model, we can use the model to make a prediction on the house price. If we have a house with a size of 100 square meters, 3 rooms, and located 80 kilometers from the city center, its price could be 520 pounds. These are my reference resources for this presentation. Thank you for your attention.